Let me show you how to solve for the reaction forces on this truss problem. So if you have a truss with a pin support on the left side, it has two reactions, AX and AY, because it's preventing movement in both directions. The roller on this side is allowing free movement in this direction, but it's preventing movement in the vertical direction, so it's going to have one reaction, which I'll label as EY. And so the first step is to take the sum of all moments around point A, because that way you don't have to worry about these two forces and we can just solve for EY. So we have this 10 kilonewton force that is 8 meters away from the point of rotation. So we have 10 kilonewtons times 8 meters. Next we have a 15 kilonewton force that is 12 meters away from the point of rotation. So plus 15 kilonewtons times 12 meters. But then we have EY, which is actually creating counterclockwise rotation around point A. I'll call that negative. You can use either convention if you want. So minus, we have 6, 12, 18, 24 meters away. So minus 24 times EY. And that's all got to add up to zero rotation overall. So 10 times 8, that's going to be 80. We have 15 times 12, that's 180. And then we're going to go ahead and add this to the other side. So equals 24 EY. This is going to be 260 on the left, equals 24 times EY. Divide both sides by 24. So do 260 over 24. That gives us 10.83. So EY is equal to 10.83 kilonewtons of force. So this is the reaction force supporting that side of the bridge. I'll just go ahead and add it, 10.83 kilonewtons. And let's take care of AX real quick. Since there's only one force pointing this way in the X direction, AX has to resist it, so it's actually going to end up pointing this way. We're going to have a reaction force of exactly 10 kilonewtons to the left. And the final step is to solve for AY. And to do that, we'll just sum all forces in the Y direction. So let's do that now. Sum of all forces in the Y direction must add up to 0. We have AY, which is what we're solving for, minus 15 here, minus 15, and then plus EY, which we just figured out, is 10.83 kilonewtons. And all of that has to add up to 0. So if I were to bring the 15 over to the right side, we'd have AY equals 15. And then I'm going to bring that over as well. So minus 10.83. And that's going to give us what? 4.17? 4.17 kilonewtons of force is holding up the bridge on the left side. And there we've done it. We've solved for all three reaction forces.